this lesson, we'll be discussing about analysis of variance, which is also known as ANOVA, which is also a good example or a good type of test or of a statistical test. And ANOVA involves testing equality between means. So in this situation, our null hypothesis will definitely be that the means are equal, and the alternative hypothesis will be that the means are unequal. Just like your test of statistical hypothesis, your t-test, your z-test, and your chi-test, which involve testing hypothesis. ANOVA also involve testing hypothesis, but in this situation, the kinds of test you are performing is on mean between some certain groups. So without wasting much of our time, let's move into what you have in this lesson. And if you're new to this channel, kindly make sure you subscribe, you like, and you share the videos with some of the other colleagues who also find it helpful. Thank you. Analysis of variance. ANOVA. So in analysis of variance, we want to test the equality between means of some set of groups. So groups of data. So I want to give you the formulas involved in ANOVA. In ANOVA, we are having 3 degrees of freedom. And just as the other type of test, you will be given the critical value of f. You will give the critical value of f, and you will be calculating your f. So you will compare the calculated f with the critical f. So in analysis of variance, you have to give degree of freedom, which is df1, df2, and df3. So df1 is given as k minus 1. df2 is given as n minus a, and df3 is given as n minus 1, where e is equal to number of groups, and n is equal to what? The total number of population. And small n is equal to number of population in each group. And note that n is equal to small n times k. That is, if you are having 4 populations in each group and you are having 5 groups, so your total population is what? 4 times 5. Please take note of that. And you should also take note that your calculated f is given as MSB divided by MSE, where MSB is your mean square between groups, and your MSE is your mean square of error. So that your MSB is equal to SSB, sum of squares between, divided by df1, degree of freedom 1, and your MSE is equal to SSE, sum of squares of error, divided by df2, divided by degree of freedom 2, and your SSB, sum of square between, is equal to summation of n, small n, into the square of the mean between the groups, minus the overall mean, square, and your SSE is equal to summation of the mean in each group minus the mean in each group squared, such that your overall mean x bar is equal to summation xi divided by what? Divided by k, divided by the number of groups, where xi can what? X1 plus x2 plus x3 and so on, divided by k, divided by k, divided by k. So we can say plus xk plus xk plus xk, and that's that about that. So that's everything that is involved in analysis of variance in ANOVA. So without wasting much of our time, let's move into an example. So this example says the data below gives the score of NSC students of given subject areas in ED 224A micro-teaching theory. Test whether the means of different groups are equal. So automatically your null hypothesis is that the means are equal, and your binary hypothesis will be that the means are unequal. And we give the critical value. Take critical value at 5% level of significance, 5% level of significance, 28, and so degree of freedom, to be equal to what? To be equal to 2.9467. This information in the bracket has a degree of freedom. So I don't know if it's your DF1, your DF2, or your DF3. So there are certain degree of freedom, but this is your DF1. 3 is your DF1. But when you calculate it, you get to know the degree of freedom in which these two are. But your 0.05 is your level of significance, and that's 5%. 5 divided by 100, that's 0.05. But regardless of this information, you can just calculate them. All our focus is the value we are giving as our critical value, which is 2.9467. So we are given the table. This is our table. We have the score of sample. We have treatment 1, treatment 2, treatment 3, treatment 4. So as to avoid accumulating those, let me just represent it by T. So I can say this is T1, this is T1, this is T2, this is T3, and this is T4. So I have 1, 2, 3, 4, 5, 6, 7, 8. I have about 8. And then we have 54, 55, 61, 48, 48. I have 40 here, 50, 46, and the last one is 52. Here is 62, 66, 67, 63, 52, 63, 66, and 68. Here we have 47, 48, 52, 56, 50, 61, 57, and I have 55, and the last T4, that's we have 54, 62, 75, 65, 62, I have 71, I have 70, and I have what? I have 75. So we have been able to compute everything in this table. We also have our total. We also have our totals. As you can see, the table we're given involves total. And if they are not given, if the total is not given, it's something you can just use the calculator to sum together to get your total. So the total we're given for 4. So the totals summation T1, this is summation T1, summation T2, summation T3, and summation T4. So the first total we have 406, the second we have 502, third we have 426, we have 534 to be the last for the total. So we are able to get our table. So from this table, as you can see, what will be our key? Number of groups 1, 2, 3, 4. So our key is 4. K is 4. As you can see, then automatically, what's our n? Our small n. Okay, you can say n1. n1 is equal to n2 equals to n3. n1 equals to n2 equals n3 equals n4. Because each number of our populations is equal for all the groups. And we are having our words, we are having 1, 2, 3, 4, 5, 6, 7, 8. So your small n is what? Your small n is 8. Your small n is what? Your small n is 8. So we can have that our capital N, which is what? Small n times what? Times 8. And that's what? That's 4 times 8. That's 4 times 8, which is what? Which is 32. So we are getting our A and we are getting our capital N. So we can now from there we can calculate our degree of freedom. So what will be our DF1? Our DF1 is K minus 1. We definitely do 4 minus 1, which is 3. What will be our DF2? Our DF2 equals what? Equals n minus K, which will be what? Which will be 32 minus what our K4 minus 4, which definitely is what? Which definitely is 28. What will be our DF3? N minus 1, which definitely was what our n? 32 minus 1, which definitely was 31. So our degree of freedom 1, degree of freedom 2, degree of freedom 3 have been calculated as 80, 28, and 31 respectively. So after that, then all we need to do is to determine our means between the groups, between each groups, our means between each groups. To determine our means between each groups, that is our x bar, to determine xi bar. Then after determining xi bar, we can take the total overall mean from our means of each group. So let's determine our means. So the mean for group 1, that will be our what? That will be our x1 bar for group 1. That will be x1 bar, and that will be this summation T1 divided by n. Summation T1 divided by n. But don't forget, anything we are not doing total, we need to sum everything together. You need to sum everything together before you compute this. But since we are putting our total already, so we can just compute it over here. So summation of this is what? 406 divided by what? Divided by small n, which is what? Which is 8. As you can see, we are having 8, 1, 2, 3, 8. We are having 8 data. And if you compute that, that should give you, you compute that with the calculator 406 divided by 8, that should give you 50.75. X2 bar, that's the second group. That's the mean for the second group. That will summation T2 divided by n, and that's automatically 502 divided by 8, 502 divided by 8, 502 divided by 8, that's giving us 62.5 62.75. Our X3 bar, which is summation T3 divided by n, which is definitely what 426 divided by 8, 426 divided by 8, 426 divided by 8, and that's definitely what? That's definitely 53.25. Then lastly, our X4 bar, which definitely is summation T4 divided by n, and summation T4 is what? 534 divided by n, which is divided by 8. 534 divided by 8, and that was 66.75. 66.75. So we are able to get the means between each groups. So we cannot get the overall means from that information. So to get our overall mean, X bar, so our overall mean will be summation xi bar divided by p, and that will be what? X1 bar plus x2 bar plus x3 bar plus x4 bar divided by what? Divided by p, and k number of groups is what? Is 4. 1, 2, 3, 4. That's 4. So that will be equals to what? 50.75 plus 62.75 plus 53.25 plus 66.75 divided by number of groups, which is what? Which is 4 divided by 4. So let's compute that. We have 50.75 plus 62.75 plus 53.25 plus 66.75 divided by 4. So the overall mean gives us 58.375. So I'm going to get our overall means, and we have gotten the means between each groups. So we can now get our sum of squares between, and we can also get our sum of squares of error to get our mean square between and our mean squares of error. So our sum of squares between SSB, which is equal to summation n into xi bar minus overall x bar squared, will be equal to what? Will be equal to n. What's our n? Our n is 8. That will be 8 into, for the first value, what's our xi bar? That's x1 bar. 50.75 minus overall mean 58.375 squared plus 8 into the second one, 62.75 minus 58.375 squared plus 8 into this 53.25 minus overall mean, which is 58.375 squared plus 8 into the last one, which is 66.75 minus 58.375 squared. So let's it into 50.75 minus 58.375 squared plus 8 into, so to avoid repeating 8, you can factor out 8 when using your calculator. You can decide to factor out 8 when using your calculator actually. Plus 62.75 minus 58.375 squared plus 53.25 minus 58.375 squared plus 66.75 minus 58.375 squared. 375 squared times 8. 8 I factor out. So everything is amounting to 1389.5. 1389.5. 1389.5. 1389.5. Check. So I'm going to get our sum of squares between. So we can now get our sum of squares of error. Sum of squares of error. Sum of squares of error. Can decide to get our sum of squares of error. Our SSE. Remember, SSE equals to summation of summation xi, summation of summation xi, summation of summation xi minus xi bar, summation of summation xi minus xi bar squared, to get our sum of squares of errors. But if you know that we need to get our xi bar, we need to get our xi bar, we need to get our xi bar. So we need to subtract our xi bar from these values, from each of the values, to get our sum of squares of error, to get our sum of squares of errors. So to get our sum of squares of errors, so we can let xi minus, or we can let t prime, let t prime to be equal to xi minus xi bar, xi minus xi bar squared, xi minus xi bar squared. So we can decide to compute a table for this. So this represents, this will definitely represent, let's say, T1 prime, T1 prime, T2 prime, T3 prime, T4 prime, T1 prime to T4 prime, T1 prime to T4 prime. And here we have what? We have T1, that is meansI, minus the mean for this group, minus x1. So that's definitely what? That's definitely 54 minus 50.75 minus 50.75 squared minus 3.75 squared, and so on and so on. So as to contain the space, I'll just be computing the value and writing it there. So you should be able to understand how I'm getting those values. This, that is xi minus xi bar all squared minus xi bar all squared. So that will definitely be what? That will definitely be 54. The first one, 54 minus 50.75 minus 50.75 squared. And that's what? And that's 10.563. 10.563. I have 10.563 for the first one. The second one, 55 minus 50.13. So we will make use of this graph. 50.75 all squared. And that's what? That's 18.063. 18.063. So the next one I have 61 minus 50.75. That's 10 all squared. That's 105.063. The next one is 48. I have 48 minus 50.75 all squared. That's 7.563. The next one I have 40. I have 40 minus 50.75 all squared. That's 115.563. Next I have 50 all squared. That's 0.563. 0.563. The next I have 46. 46. That's 22.563. The next I have 52. And that's 1.563. So I can keep this within my total summation. So I will bring that later. Let's go to the next one, T2. We'll be making use of 62.75 now because the x2 bar is 62.75. So let's start with the first one. That's 62 minus 62.75 squared minus 62.75 squared. That's 0.563. The next one is 66 minus 62.75. That's all squared. That's 8.563. The next one is 57 minus 62.75 all squared. That's 33. That's 70. And that's giving us 10.563. And the last one is 75 is repeated. We've done that before. 75, done that before here. So which will be giving us what? 68.063. 68.063. So we are going to conclude all our squares of errors. All our squares of errors. So we are left to sum the squares of errors. So let's sum everything. Let's start summing everything together. Here we have, for the first group, we have 10.563 plus 18.063 plus 105.063 plus 7.563 plus 115.563 plus 0.563 plus 22.563 plus 1.563 plus 1.563. Let me cross check that. 115.563, 0.563, 22.563, 1.563. You need to be very careful when computing, because if you make any slight mistake, then you've ruined everything. So we have to hit 1.504 as a sum to that. So the second one, we have 0.563 plus 10.563 plus 10.563 plus 33.063 plus 0.063 plus 115.563 plus 0.063 plus 10.563 plus 27.563. So that will give us 198.004. 198.004. So we move to the next group, where we have 9.063. 9.063 plus 27.563 plus 1.563 plus 7.563 plus 10.563 plus 60.063 plus 14.063 plus 3.063. So that's giving us 163.504. 163.504. So we move to the next one. So here we get 162.563 plus 22.563 plus 68.063 plus 3.063 plus 22.563 plus 18.063 plus 10.563 plus 68.063. So we have 37.504. So we are going to get all our squares of error. All our squares. So we want to find the sum of squares of error. We want to sum everything together. We want to try to sum everything together. sum of these sums. So we can now have what 281.504 plus 198.004 plus 168.504 plus 375.504 plus 375.504. So that equals to 81.504 plus 198.004 plus 163.504 plus 375.504. So that's giving us 1018.516. So we are going to get our SSB and we are going to get our SSE. So we can now calculate our MSB. Our MSB being of squares between, which is equal to what SSB divided by degree of freedom 1 EF1. And SSB is equal to what? Is equal to 1389.5 divided by DF1. What's our DF1? Our DF1 is 3 divided by 3. Also our MSE, which is equal to what? SSE divided by what? DF2 is equal to what? 1018.516 divided by DF2. Our DF2 is what? 28, which is equal to 1389.5 divided by 3. That's 463.167, and our MSC 1018.516 divided by 28. That's 36.376. So I'm going to get our MSE and our MSB. So we can now compute for our head. Because our head is equal to what? MSB divided by what? MSE, which is equal to what? Which is equal to 463.167 divided by 36.376. So if you do that very well, you have 463.167 divided by 36.376. So this round of 12.733. 12.733. We have been able to complete all our values. We have been able to calculate all our needed values, all our required values. So we cannot summarize everything we have calculated into a table called table of ANOVA. It's just as if we want to summarize everything we have computed into one table. So by drawing a table of ANOVA, so the table of ANOVA is something like this. Here we have a table of ANOVA. Source of variable, of squares, degree of freedom, and we have the F ratio, which is evaporated F. We have the F ratio. So here we have what? Between groups, and we have what? We have error. So you can have the total as well. So here, we have sum of squares between groups, sum of squares of error. Here we look for the degree of freedom, and we have a degree of freedom. You can also create a column for your means of squares, your means of squares. So here we have this should be for the degree of freedom, DOF, means of square, so we have means of square between means of squares of error, we have degree of freedom. So the first degree of freedom, DF1, because what we do for DF1, our DF1 is 3, we got 3, our DF2, we got 28 for our DF2, our DF3, we got what? 31 for our DF2. So our mean of square between mean of square between groups, we got what? We got 463.167. Our mean of square of error, we got 36.376. Our sum of squares between, we got 1389.5, and sum of squares of error, we got our sum of squares of error was 101.8.516.516. So if you sum everything together, your sum of squares total, you can decide to sum these together. So you can decide to our mean of squares of error, our mean of squares, you can decide to sum them together as well and put it there. So what do we get for our F ratio? Our calculated F, we got our calculated F is what? 12.733. So if you add this together, you can put it here. If you add this, you can also put the value here. So this is everything about our table of ANOVA. But don't forget, we are not done with the question because we only got our calculated F. We haven't concluded. We haven't compared it with our critical F. So recall that your critical F, your F critical is given to be what? Your F critical is given to be, our F critical is given to be 2.9467. That's our critical F. Our critical F. And so plotting that distribution, what do you have? This is 0. So 2.9 will be around here. 2.9 should be around here. So anything that falls within this region, you are going to reject that hypothesis. Which is our critical F. So let's say what our calculated F? Our calculated F is 12.733, and 12.733 will be after 2.9467. It will be in this region. And anything that falls in this region we reject. We reject what? H0. Reject H0. So the first thing you need to do when you start the question is to define your H0 and H1. I don't think we remember to define our H0 and H1. So please, when you want to solve your question or your problem, the first thing you need to do is to define your H0 and H1. And I already do those. like this case, your h0 should be that the means are equal, and your h1 should be that the means are what? Are unequal. So here you go, you are getting h0. So you can say since f is greater than critical error, h0 is what? Is rejected. Is rejected. That is, the means are what? Are unequal. The means are unequal. The means are unequal. And that will be the conclusion to that problem. So at this junction, this problem is going to bring us to the end of the lesson. If you're yet to subscribe to the channel, kindly make sure you subscribe, you like and share the videos with your colleagues. Also, you'll find it helpful. Tutor Bosun is here. Thank you.